Hello, everyone. Welcome back to RPA and Intelligent Automation Live. During this session, like the previous ones, we'll take your questions. So for any of you who are joining this session for the very first time, very quickly, there is a questions box on your control panel, and that's where you go to submit questions to our presenters. And those questions will be relayed to the presenter during the live Q&A at the very end of the presentation. So if you're joining us for the first time right now, please make sure you become acquainted with the questions box and go in there and you may say yes or type anything there. I can see that. The presenter cannot see that until the very end when I relay to him the questions about the session. So we have had very engaging presentations and interactions through the questions box. And I'm looking for another great presentation with Rajesh Rao. Rajesh currently heads the RPA and conversational AI chatbot COEs at Nokia. He is responsible for globally implementing these technologies to deliver extreme automation benefits. Prior to this role, Rajesh was heading platforms automation for HCL's business services division, where he delivered automation solutions to multiple large global companies. He has held global leadership positions in these areas with people and P&L responsibilities, including board positions. He holds a business management diploma from XLRI and a Bachelor of Technology from the Indian Institute of Technology at Kanpur, India. Rajesh, really a pleasure to have you here. I'm going to let you share your presentation and go on. Thank you.
Thank you, Jose. Is everybody able to see my screen?
Yes.
Great, thanks. So this is a story that I'm going to tell in 4 chapters. This is in form of a story. First chapter will be around how we used standard RPA to solve part of a very key process that is there in Nokia's landscape, operational landscape. The second one is once we solved that problem using the standard RPA products and methods that were available, we wanted to do more. And then what was the journey like in terms of figuring out how do we do more? And I will tell you some more details about the problem itself when we are in the second chapter. The third chapter is a more interesting chapter where which basically details how we solved the problem, right? And what some of the results were, and what does the outlook for such problems look like. And I will round it off by the fourth chapter, the last chapter, which is more around reflections, sitting back the last 3-year journey that we took around this, and then what were some of the summary distillates from the learnings that we had. So without further ado, let me just launch into this, just to give you a sense of the locale and the atmosphere of where this story is occurring. So this happened at Nokia. And Nokia, as you know, is a technology giant. It has a history of innovation. It is an innovation pioneer. Even today, with 5G, it is leading the pack with breakthrough technologies. In terms of one dimension of aspect of how Nokia is internally, one sense you can get of the innovation culture by the Nobel Prizes Nokia has won. So lots of prizes Nokia has won, 9 Nobel Prizes in total. 4 Turing prizes. The Turing is the highest prize that one can get for in areas of computing, and actually even an Oscar. So this was way back in 1930s, but one Oscar as well. The process itself is the main character of this story, and then this process occurs in an area of Nokia's business called network monitoring. This is part of the services business of Nokia, and I'll talk more about the process in the subsequent chapters. So diving into the first chapter, which is the road to the beginning of the tunnel, right? So essentially how we started out solving this particular process by the standard RPA products that we had onboarded at Nokia, and then what happened till the point when we solved that problem using the standard products that we had. Now the process itself is alarm monitoring, right? So you and I, all of us use cell phones for both mobile and data. And this is backed by a very robust, typically very robust large networks of mobile towers which have lots of devices. And What happens is that within this mobile network, mobile and data network, if there are errors, there are alarms that are generated, right? And these alarms are essentially fix me alarms, and they essentially signal that there is something wrong in the network. In the next step, once these alarms are generated, they are all collected centrally in a system. Then they are passed on to a team of humans, human operators, which is essentially a low-level L1 team, whose job is to correlate these alarms that are coming from the network and then create trouble tickets. Now, some of these trouble tickets are solved by the L1 team themselves. These are the easy problems and the easy alarms. And once that the L1 team cannot solve, they pass those on to the more expert team, which is the level 2 team in our operational parlance for this process. What we wanted to do then was to automate this part that is circled that you see on the screen. So alarm correlation. So take a bunch of alarms and correlate that to a single problem and then create a ticket out of those alarms. We wanted to automate this, and part of the solution itself, we wanted to automate the part that L1 team was doing. And with the standard product that we had onboarded way back in 2016 at Nokia, we solved this problem. I mean, if you look at some of the results that came out of this, in terms of number of tickets that were being handled automatically by the robot, we had an increase of 40% more tickets. So now this is a reflection of the average handle time that was shortened because of using robots. And in terms of turnaround time, it was almost halved, right? So 50% more tickets we were able to solve. Now, once we had solved this, and this was quite one of the first implementations of the standard RPA product that we had done within Nokia in this particular area, and then we were pretty much very pleased with what we had done. However, we started looking at the process of what we had automated. So in this particular process of alarm monitoring, we had automated by using the standard RPA product only to about 30% of the process. And there was still this 70% of the process that was not automated. The standard RPA product was giving great results, and we were able to have commensurate reduction in terms of number of human beings that we were able to reduce and redeploy to other processes. So the question to us was what we can do to grab the rest of the pie, what we can do to grab the rest of the automation potential that is sitting out there beyond the 30% that we had automated using RPA. And that straight away brought us to the state what on reflection I can only say were equivalent of the 7 gates of hell. Now we only had 2 big problems, or maybe only 2 gates, but let me talk a bit more about that. So going back to the process that I had shown you earlier, if you see on your screens on the left side, the box, the light peach colored box that you see, that was the part that we solved using the standard RPA 1.0 product. And the part that we wanted to automate now was the right side of this slide that you see, the L2 team. So we wanted to see how we can solve the work that the L2 team is doing of solving the hard problems, the hard tickets, the tickets for which the solution was not easy. Now, if I were to tell you a little bit about this problem solving heuristics and the methods that this L2 team was using, essentially, this team is a very experienced team, comes with a lot of expertise and a lot of training. And a lot of what they do is not codified in the sense that it is not, it is problem solving on the fly, right? Backed by experience and expertise and the learnings and the trainings that this team has, right? And then, but the thing was that automating this part would have been extremely rewarding, because alarm monitoring globally, all telephone networks need this process, right? And L1 part one, so almost everybody in the industry at this point, at least in 2020, has automated the first part. And I believe some would have automated some parts of what I'm going to talk about, but we are talking about 2017 here right now, right? So the rewards were going to be very, very high. And in terms of automating the process, we would have automated from 30% of the L1 team's work, we would have automated something like 60 to 80% of L1 team's work, and almost 30% of the L2 team's work. Now, to give you a sense and the size of the complexity of the problem that we had set out to solve, right? And this is the first gate that I was talking about. On your screens, you see two boxes on the top, right? So these are this is information about two of the alarms that the network might generate as errors, right? So let's take the box on the left. Now, what you see is some sort of a flow diagram, right? It looks like a flow diagram. Now, this flow diagram is one of the solutions, just one of the solutions of solving an alarm. Now, there could be scores of these flow diagrams that one would need to solve potentially given an alarm, right? And similarly for this box on the right. So again, this box has a resolution state diagram. This is one of the states of the resolution. And there can be multiple resolution states that can be there for solving a particular alarm. Now, this is the first part of the problem. Actually, the problem is more complex, but that is out of the scope of this particular session that we are having. This is just one part of the problem. The second part is, even on an 80-20 principle, the number of alarms that one would have to solve this L2 team automation problem would be in hundreds, right? And then imagine most of us do RPA, and we have seen such diagrams on process modelers that we have. Most of our products give also these process modelers. But imagine in RPA 1.2, for hundreds of alarms, each of those alarms can have scores of solution states coding that in RPA 1.2. I mean, practically, you cannot have a viable business case if you wanted to do it the standard RPA way. And the problem that we were trying to solve was how we could replicate what the L2 team, the expert team, was very easily doing. So in a sense, if I were to equate, we wanted to do part of what the expertise of the L2 team that was enabling them to solve this problem just by thinking, and to codify that into a computer solvable problem, right? So then at the same time, 2017 was a big year for step change, so to speak, in the marketplace for RPA products. Almost everybody had started talking about the kind of cognition, the kind of automation, which is AI and machine learning driven type of automation that they have, right? So we started then a market search. I mean, there were two threads of the search. One was how one would then solve this problem using AI. We started looking at AI, and we also started looking at what these products had to offer. On the bottom right of your screen, you see a summary of one of the analyst reports that is be presented here in a different form. Now, if you look at this product, look at this chart, there is even cognitive computing, and some products are also mentioned as cognitive computing. Our research, this is our research, so this is no reflection on the products themselves. There may be more to the products since 2017 and now. Our research showed that either these products did not have the kind of cognitive capabilities where we were looking at, or if they had, the applicability was very narrow and certainly not applicable to us. One product I would like to mention that came extremely close to what we wanted to solve, but of course, all great but no cake, was Arago. Now, Arago uses uses graphs essentially to solve problems. It has some genuine AI built into it, but the applicability we found would have been in solving more infrastructure type of problems rather than the telecom network type of problems that we wanted to. So what did we have then after months of demos, scores of reviews with analysts, and many man-months spent in research? We basically had this. So it was a very uphill task, and then we did not really have a solution. Our thinking at that point had come to a point where everything was not looking very good, and this is where we came to a realization. Now, this realization is what brought us out of the tunnel, the problem state that we were in. The realization was that Nokia has an awesome artificial intelligence, machine learning capability inbuilt in inside the house itself. And this was not an aha moment, so to speak. So there was no eureka that we can do this. I mean, this was a slow realization coming to a point that there is nothing in the market that is off the shelf that is available, and if we really wanted to do anything about this problem, we would have to develop something from ground up, right? And then that was quite enthusing in the sense we were dealing with unstructured data with patterns that were there if you looked at the data set of solution. And the decision was then to insource this development of algorithm. I mean, at that point in time, we were even thinking of how we could do self-learning. How would it look like if we wanted to do self-learning and self-designing robots, which can have multiple applicability, especially in complex areas like networks and high technology areas like networks. Now, this slide is going to be a bit of an anti-climax because I'm not going to get into the details of exactly what was the process of doing the algorithms, one, because of trade secrets, and second, you would very quickly realize what bumbling fools we were in the beginning. So what I'm going to show you is a distillation of experience of the period in which we solved the problem. However, I am going to show you what the solution design for the POC and then the eventual product, the design is some sense of design I will give you. So if you wanted to undertake something like this, you have to start by doing a POC or an MVP, a minimum viable product, right? So the goal here is to convince the business that the technology works, right? Now and then you have to run a parallel thread saying that what you are trying to do is not a one-off, right? So you choose a problem, you select a problem that is scalable. In our case, the problem is definitely scalable across multiple customers. So alarm monitoring is for every network that Nokia manages, right? And so there is certain scalability in the problem that has the promise of high benefits as far as this particular use case is concerned. And then we combined that with other potential problems that could be solved by this formulation, where we are using RPA as for orchestration, not for the logic part that one can build in RPA. RPA only for orchestration, and as we like to call it, using RPA as hands and the algorithm as the brains. And there are scores of, even in your company and in your industry, if you look through what you can solve through this combination, you will definitely find a lot of examples. The thing would be this number two. Point number two is that which of these problems will yield you a business case that is viable. And then after that, the third is, of course, to go and deliver. Once you have convinced the leadership and the management and you've secured funding, to go ahead and deliver. Now, one point that I will emphasize now, and I will emphasize again as well, is to set the right expectations. Now, this basically, what I'm trying to say here is that any AI ML based solution is inherently statistical in nature, right? So there is nothing like 100% in an AI. So there is this lack of predictability can manifest itself in delivery timelines being missed, results not coming up to what you would like within the timelines that you want to deliver the results in. So setting the right expectations with the business is extremely important. And there are some points to remember, right? So you have to scope the POC just large enough to show that it works, right? And then you combine that with a business case, a larger business case, of which POC is just a small part. The technology demonstration is just a small part. You have to select your algorithm well, and then once you start solving the problem, and as it happened in our case from 2017 till last year, was that you have to be prepared to change the algorithms if your results are not coming to the liking that you have that you want, or the results that you expect, right? I mean, the algorithm that is currently implemented for this particular problem bears no resemblance to the first POC algorithm that we implemented. So there has been so much change in the algorithm, not only in terms of fine tuning, but in the fundamental way the algorithm was designed and the algorithms that were picked. And the third one is more around how you go and do the drumbeat around the company. So you have to go and memorialize the POC that you're doing and the results that you get from the POC. And like I said, you have to, even the POC should demonstrate that there is business benefit, either in terms of operational, and if it works in your case, also hard benefits, right? Memorialize the POC. So then let me come to how the working prototype for the initial POC in 2017 looked like, right? So there are five boxes that you see. The first box here is the ticketing system. This is the place where the alarms are getting created by the RPA 1.2 solution. Follow my pointer. Then the second is the RPA robot itself, which is doing the orchestration on the quote-unquote hands part. The third one is the AI engine, which is actually generating the solution using the algorithm. The fourth one is operations team, and I'll come to it, why they are part of the solution flow itself. And the fifth one is where the alarm was generated, the network elements where the alarms were generated, the place where the error is. So the first step, in the first step, the RPA robot goes and fetches the alarm details from the ticket, and then passes on to the AI engine. The AI engine then provides the solution. In our case, you have to remember, even in the POC, you can't simulate a country-sized, global-sized network. So essentially, whatever we were doing on live networks. And live networks basically mean that if you create a solution and you go and your solution goes ahead and brings the network down or part of the network down or creates an issue, that is definitely not acceptable. I mean, in practical terms, it would mean that calls drop. For example, one of the things that can happen is calls will drop. So we put a safety step, which was an authorization step at the POC stage. So any solution that the AI engine recommends, RPA then presents through a web form to the operations team. Operations team then authorizes. If the operations team authorizes, then the RPA robot executes that solution. In our case, the solution essentially comprised of, to solve that problem, firing a bunch of MML commands. Right. So this is the working prototype of the POC that we generated. Now I will show you what the pilot and the first base use case that we implemented that was then scaled up. Right. So this is slightly complicated. What you see on your screen is slightly complicated. So I'll go in a sequence. So pay attention to where these circles and the bullets are coming. Right. So and where my pointer is. So in the first step, the standard RPA solution, the ticket is pulled by the robot and the alarms details are extracted by the RPA 1.2 robot. This guy here is the RPA 1.2 robot. Right. Then depending on the ticket details, there can be some very basic solutions to give you very basic actions that this robot can take that can solve that problem. So for example, if your computer goes bad, one of the solutions you can always do is to try to restart the solution. So some basic actions like resetting or in other words, restarting that RPA robot 1.2 takes. Now, if there is no solution that is available, a rule-based solution that is available with RPA 1.2, if there is no basic solution, then all the problem details are then passed on by the RPA robot to the AI engine. The AI engine, this is step number 2. If the AI, now two scenarios can occur. The first one is that the AI engine has a solution and the AI engine is 100% certain of the solution. Now, like I mentioned before, this is a blue moon with pink dots. So this never happens. Likely what would happen is that the AI engine would recommend a solution that has the highest degree of confidence, and then passes that on to this guy, which is at circle number 3, for approval. Right? If the person approves, then the human being confirms the solution, the human operator confirms the solution, and the solution is then sent to the robot for auto execution. And then the robot obviously carries out the auto execution. What then also might happen is that the human operator does not like the most probable solution that is offered by the AI engine. The human rejects the solution, and does the manual execution in terms of solving that alarm manually by directly acting on the network element. The other next two steps are important steps in this. The first step, and they involve learning. So whatever solution that was, whatever alarm that was or ticket that was not solved by the AI engine, and for which the human being proposed a solution, that answer is that solution is passed back to the AI engine, steps 6 and 7, passed back to the AI engine for learning. And this is where the feedback loop is created and continuous learning that happens. Now, in all of this, whether it is 3 or 3A, 4A, and 6 and 7, the recommendation is to automate as much of it as possible, right? So the key part is this steps 6 and 7. If you can automate that, that will be that is great. Okay. So what do you do when you have done a POC and then you also have a solution that you can do in your hand and your engine that you've created sort of working, and then it's giving the solutions that you like, right? So essentially you project manage the heck out of it, right? And that's what we did. Again, the thing to remember in this is that the AI ML solution, this is not like it is in every other aspect, it is like a normal software development project, right? Or any RPA implementation project, right? Except for the fact that it has a component that is probabilistic in nature. In terms of the solution that it provides is probabilistic in nature, which then means that even in runtime, you might have situations where results don't come, or if the results come, then they come late, or they never come, and you need to make fundamental changes in your algorithm or your input. So again, setting right expectations with business and operations is key in RPA 2.0 type of solutions. Okay, so then some results, right? So in runtime, our solution essentially predicts each of the commands to an accuracy of 90%. So like I said, what is happening here is that the network, again, revisiting the problem statement and the solution, the network is generating errors, and either the solution or the person is fixing the error by firing certain commands to the network, right? So for a single command prediction of the solution set, the accuracy is about 90%. To solve the alarm end to end, typically 6 to 8 different commands are to be fired in the right sequence. There, our accuracy hovers around 60 to 70%, and believe you me, this is a big result. How it looks like in runtime in terms of how we track and monitor. Just focus on the top part of this chart that you see. There are dark blue lines, and then there are gray lines. The dark blue line is essentially whichever alarms that are in scope, and the gray lines are the alarms that are solved by the robot. So pretty much good. So then reflections, right? So in terms of reflections, let me just round it off. Let me start by proffering what a standard general solution of RPA 2.0 may look like, right? A solution in which there is RPA and then you have an algorithm augmenting as brains, right? So there are two parts to the general solution. One is the learning process, and the second one is the execution process. And there are 4 actors here. One actors are the human operators. The second is the AI engine itself. The third one is RPA robot, your standard RPA robot. And then you have the human expert, which does the resolving if the AI engine does not offer the solution, and then recording that solution that the human expert has provided and cycling that back to the AI engine. So you start with the manual transaction that are being processed by the human operators. Your first step would be, once you've decided how you would solve the problem in terms of selecting your initial algorithms, is to collect data, right? So which will form your learning data set, which would essentially help the algorithm learn to get to your final AI solution. So you can collect this data manually. So in our case, that there were logs, they could be collected manually. You can automate that log collection, or even still in your cases, in your process cases, there are many RPA products today that come with process recorders. You can use those recorders to collect this learning data set. Use that learning training data set to help your algorithm learn. Uh, and then you end up with an AI ML engine that is capable of providing solutions to whatever learning set that you had provided. And then the fun part of execution starts. Essentially, in the execution process, a transaction is initiated by the RPA robot. In our case, it was fetching the alarm ticket details and the alarm details in the ticket by the RPA robot from the ticketing system. Solution fetch by the RPA robot from the AI engine. Then the RPA robot executes the solution. This is essentially, you may have an approval step here, but this is essentially, in our case that we are discussing, acting on the network elements to solve the problem. If the solution is not acceptable for controls that you have put in terms of the approver step or whatnot, the problem then goes to a human expert. If the AI solution exists, of course it does not come, but if it does not exist, then the expert provides the solution and then solves the problem. And whatever it has solved, those actions are recorded, and then they are fed back to the learning part of your AI system, where you create a feedback loop and keep enhancing your AI ML engine. So this is how a general solution might look like. So what are the key takeaways? The key takeaways, the first one, the biggest one, is that you need to get the business buy-in that your AI ML solution will never be 100%. I mean, the current thought is that, like human beings, in any process or any actions, they can produce damage. So can AI systems, and you have to accept some damage and do steps to mitigate it. Accept that the AI solutions will do some damage, and then put controls around it so you can solve that. And this buy-in is important. So to a business that is used to definite solutions, this is not an easy step, but you can convince them by the steps that I mentioned. Do a POC, show the technology works, put safety steps like approvers, etc. The second one is data. So any AI solution essentially depends on having a lot of data, right? And so in our case, what was very important was to have a practical collection strategy, right? Typically, operations are not staffed to collect a lot of data for you. And in our case, the alarm volumes and the monitoring are so high that this collection itself is a task. And the recommendation then would be that from the get-go, you have a very practical collection strategy that has a lot of automation in it. Currently, today, our collection strategy has automation built in it. The third one is delivery expectations. I've been harping on that. This is extremely important. This is not only important to the operations on the ground, but also to the business that is funding you. That they may or they may not, there may be scenarios in which they will not get the results on the time that you promised them. The fourth one is business case. So you have to have business case right from the POC stage if possible, that you show some hard benefits, that your business case, your POC itself is showing some hard benefits. Always remember that depending on how you're organized within your organization or your company, how automation is organized, or how RPA is organized, or how AI/ML teams are organized, you may be the RPA team that is trying to do AI/ML, which is not your domain, right? So this partnership with business and then showing hard business benefits is extremely important. The fifth one is around choosing the right RPA product, right? So like I mentioned before, there are some products that obviously the basics have to be done, but there are some RPA products that, for example, come with process recorders. And this can help in your data collection immensely, because collecting data is a continuous process, right? Because environments change, inputs change, sometimes the process change, the KPIs change, and then you have to keep fine-tuning your AI algorithm as time goes by, right? It is not a static thing. So collecting data is extremely important. And the sixth one is slightly counter to what I have been talking all along, is that from the time when we started and today, there are a lot of cloud-based AI ML platforms that are available. So while you may choose, depending on what capabilities you have in your company, you may choose to do this algorithm by yourself, and you may just have to, because you may not have, your problem may be very unique. Every problem is unique, but yours may not have a solution that is ready-made available. So potentially you can consider using some of these ready-made platforms, right? So I will give you examples. Some of the big ones are Azure's cognitive services or IBM Watson's services. And then even there, they are not extremely general AI solutions, right? So you have to pick the right problem that you want to solve and then match it to the cloud solution that is available. And then you save a lot of this pain that you can potentially save, depending on your problem, a lot of pain that you would have. Right? So these are the 6 key takeaways. Now, if 6 is too much, then just remember these 2. Your first use case has to bring in hard business benefits, right? Your POC has to show some operational benefit clearly, other than the technology demonstration, and you have to, and then you top that off with potentially a scale-up type of plan or other viable plans, right? Don't promise too much. Don't end up with a hairy back, as they say, that you deliver, that you promise something, then you don't deliver, then you promise something more. So choose your problem very carefully, right? Both in terms of business benefits and also in terms of how solvable that problem is going to be. And the second one that I would like you to take away from this would be to set the right expectations, right? So set the right expectations from the get-go to the business. Um, I am at the end, and I had a very nice Dilbert cartoon that I wanted to put here, but unfortunately the corporate masters of Dilbert have licensing agreements, so you can go yourself and on dilbert.com and search artificial intelligence, and you would get a bunch of those. So that ends my presentation, and I think we can take some questions if the audience has any.
That's fantastic. Fantastic, Rajesh. Thank you so much for such depth and details on the approach, and very insightful, very helpful to understand the behind the scenes on of the technology and the implementation, the approach you had. I have to ask, first of all, when I look at what you have done there, I see some parallels with potential applications for IT support. Do you think a solution like the one you have developed here can be applied to IT support?
Yes, it can be. In principle, it can be, because IT, a lot of, so to give you an example of IT support, so infrastructure monitoring, for example, right? So infrastructure monitoring also has deals with similar problems. You have to do some housekeeping tasks like cleaning up memory overloads, etc. So yes, one can, but for infrastructure monitoring, there are already really good solutions that are available. And depending on the problem, one may not need to develop an algorithm from the ground up. But there are many solutions and very, very, very good products that are available today.
Very good. I'm going to pose you some questions from the audience here. And Susanna asked about, did you assess how the human operators feel about only confirming or rejecting RPA proposals? There is that process in the step there where they're confirming or rejecting RPA proposals or choices. How was the people side of this change in a broader context?
The people side of this change is not very different from any automation project that you do, and that is a problem of automation, in the sense of you have people who are doing work and then you automate their work, right? So this is not specific to this, but the solutions are as they are for the general problem, they are for this. So you have to figure out a reskilling plan. Your communication needs to be extremely important. You have to, in our case, we essentially, these guys are masters of that automation, this AI engine, if I may put it that way, right? So that aspect is taking care of that in some way. But yes, Rescaling, that is one. Communicating well, that is another. And then pushing them to more value-added tasks. That is something that I would recommend. But that was a great question. That was
And
a great question.
VJ asked a question about the naming of the bots. Are there any recommendation for naming the bots?
No, we didn't have any name, but I mean, I would take inspiration from Dante, at least for our bot.
Very good.
So no, we didn't have any names for these bots, but you can have some really great ones, of course. The market has
Very
used
good.
pretty interesting.
Luis Felipe had a question about SLA compliance and how does the solution perform in terms of SLA compliance?
That is again a very excellent question, and let me then touch upon the aspect of this solution and the way we set up. So each of these trouble tickets also has a priority on it, right? So in our case, there were priority 1, which was the highest priority, and then the lowest is priority 5. Our solution was only doing priority 4 and priority 5. So we have not come to a point, not only for our solution, but even otherwise in general in the industry, where when you're working with a live network, you can essentially priority 1 tickets. If you go wrong in solving a priority 1 ticket, of course they have stringent SLAs, but you can also bring the network down. So ours were 4 and 5, and the SLA compliance were very lax. So in case a AI engine missed the solution, we of course could then pass them on to the human operator.
Very good. Very good. Erwin asked a question about the probabilistic approach. Hold on, let me take a look at what he asked here again. He says, you talked about the probabilistic component of the system, and he was curious about how do you explain that probabilistic component to the stakeholders. If you have a simple analogy to explain it to people in the business, and how do you deal with that, explaining this probabilistic approach to the stakeholders?
Well, in our case, it's who you go first and create your sponsor, so to speak, and the person who would evangelize from on your behalf. So you have to pick somebody who understands this inherent nature of AI and algorithms, that your solutions will always have a confidence level attached to it, right? So once that person is onboarded, then you can, together with that person, you can go and say, this is an inherent feature of this technology, if I may use the term feature for this, that your solutions are not going to be 100%. So then it is a leap of faith that your business and operations folks that they need to take in terms of working with AI ML in general, and balance that with the business benefits that they can potentially get. So finding that sponsor who understands, and then taking help of those sponsor or sponsors to go through the organization would be the way I would recommend. I mean, in our case, we were lucky in the sense that our business sponsor, where the process lie, Mr. Dhingra, he was quite proficient in this particular area.
That's good. That certainly helps a lot when you have a champion like that behind the project.
Exactly.
We have time for one more question here, and I'm going to pick this one from Cameron. Cameron is asking if you can elaborate a little bit more on your data strategy and that you use for the machine learning algorithms. Did you use historical versus real-time current data? What type of data did you use to train your algorithms?
Like I explained, so it is a combination. So to begin with, you have to use historical data to make the algorithm come to a point where we can start solving the type of problems that you have defined. So we defined these are the tickets that we want to solve. We use the historical data, to for those particular tickets and alarm types to to train the algorithm. And then as time went by, there is a feedback loop that is created, which is then constantly increasing the learning on the fly. So the graph that I had shown, which had lots of bar charts, the bottom one, which I didn't go into today, at least in this session, is about how the learning is happening on real time. So it's a combination of both. One, initial training data with the problem definition that you have, historical data, and then as one goes along, they create a continuous automated feedback loop. So I would stress on that, not depending on people, but creating an automation that feeds the data back, which is what we have today.
Very good. Rajesh, one more time, thank you so much on behalf of everybody who's attending today for a wonderful presentation, great insight on a very challenging but rewarding project that you have led for Nokia. This is really terrific. Thank you so much for sharing that with us.
Thank you. Thank you again for giving me the opportunity, Jose. Thank you very much for your support.
Thank you. All right, ladies and gentlemen, we will have finished the session, and we'll start the next one on top of the hour. And you do not want to miss the next session. We're going to have Ray Fakay, solutions architect and specialist on RPA, and he's going to talk about a lot of different aspects about scaling RPA and RPA solutions, and a lot of very interesting topics on his presentation, including the big question, which is, does robotic process automation takes jobs away? And he has done a bit of an evaluation on that. He's going to share with us. So again, as you close this session, don't close your browser. Close the GoToWebinar window, and when you do that, we close your control panel. There's going to be a pop-up box, and there will be a short survey about any feedback related to this session or any additional questions you may have. You can place them in there. And we'll see you again in the top of the hour, 5 minutes to the hour. We'll restart the new session. Thank you very much.